Greetings from Team Keep Learning. In this video, we will see a very important concept in probability called expected value. So let's start. Expected values. So what does the expected value means? Expected value means, by definition, the average outcome we expect if we run an experiment many times. Okay, if I am running an experiment many times, so the average outcome I will be expecting something, because if I am doing research, I would have start with some hypothesis. So the average outcome I am expecting while running the experiment many times is called my expected value. So now we will understand some basic things in this expected value while reading probability. So suppose you have flipped one coin. You have flipped one coin. It was flipping a coin once was a trial. It was a trial. So flip and record outcome. If I am flipping a coin and if I am recording the outcome, it was a trial. It was a trial. But if I am repeating it several times, if it is multiple trials, then it is called an experiment. Then it is called an experiment. So suppose if I am tossing a coin, if I am tossing a coin 20 times, if I am tossing a coin 20 times and I am recording the outcomes all the 20 times, so I will say that it is a single experiment with 20 trials. Single experiment with 20 trials. Why single experiment? Because all the times it is a coin only. All the times it is a coin only. So it is a single experiment with 20 trials. And this probability, this kind of probability, when we calculate, it is known as the experimental probability. It is known as the experimental probability. And the formula for this will be P of A, that is probability of event A occurring, will be equal to successful trials upon all trials. Probability of A equal to successful trials upon all trials. So I hope experimental probability is clear to you. Now we will go a bit deeper in the expected value. When I am calculating expected value, what we will do is that I have already told you the outcome we expect to occur when we run an experiment. When I am running an experiment, I am expecting some outcome. So it is known as expected value, and we denote it by E of A. We denote it by E of A. Now we will take one simple example. We will take very simple example. There are times when there is categorical outcomes. There are times when there are categorical outcomes. Categorical means outcomes which are well defined. Which are well defined. Like this. So ace of A will be 4 cards only in this. The ace will be 4 only in this, and spade will be 13. These black cards are 13. So 2 black and 2 red will be 13, 13, 13, 13. Total of 52 cards. Okay. So now I want to calculate the expected value of this ace of black spade. Ace of black spade. So I will go like this. Total cards are 52. Spades are 13 in it. Spades are 13 in it. So I am finding the probability of finding out a spade when I am shuffling the cards. So the simple probability will be 13 by 52. P of A equal to 13 by 52 equal to 1 by 4 equal to 0.25. 0.25. And this trial I did 20 times. I shuffled the deck of cards 20 times, and every time I have drawn out a single card, and I checked whether it is a spade. It is a black spade. So I did this trial 20 times. Now what I will do? P of A, probability of A, in this case it is 0.25, because I have already calculated it is 13 by 52. Black cards will be 13 in numbers and 52 is the total cards. 13 by 52. And I have repeated this experiment 20 times. Correct? So 0.25 into 20 will be 5. So out of 20 trials, expected is 5 times black spade will come. Expected is 5 times black spade will come. So this is known as expected value. This is known as expected value. This is a form of probability only, but here we are clear cut saying that if you are shuffling the deck of cards 20 times, there is a probability that 5 times you will obtain black spade. That is what it means. Now, we will see for the numerical outcomes. In this, sample space will be equal to all the outcomes. Of course, whatsoever numbers are available with us, same will be the equal to all the outcomes in the system. So suppose my sample space is ABC. My sample space is A, B, C. So the total probability, the total expected value will be A into probability of occurring A plus, here you have to keep in mind, plus B into probability of occurring B plus C into probability of occurring C. This total will form the expected value. Now we will see one example. Suppose this board, arrow holders board, is divided into 3 different rings. Outer ring A, middle ring B, and the core ring, the last ring is the C. So if you are able to hit the arrow on the C, you will obtain 100 points as a reward. If you are able to put it on B, you will obtain 20 points. And if you are putting on the outer one, of course the marks will be lowest, it is 10. And the probability of putting the arrow on the outer rings is 50%. It is 0.5. On the middle one is 40%. And the last one and the core one, which will be most difficult, is only 10%, 0.1. So my expected value on my expected reward number will be, E of x will be 0.5 into 10, 0.5 into 10, 0.4 into 20, plus 0.1 into 100. This answer will work out to be 23. This answer will work out to be 23. So this is an expected value. Now here you can see one drawback. As per calculations, expected value is coming 23. But in our marking system, nowhere 23 we can achieve. Either one can achieve 20 or 10 or 100. So in my next videos, we will go further deeper in this and we will see some frequency tables to cater this or to encounter this uncertainty in the calculation of expected value. So basically expected values we can use expected values to make predictions about the future based on the past data. So I hope expected value is clear to you. If you have any feedback or doubt, or if you would like to make any suggestion, kindly direct it on the given mail, or you can comment it in the comment box. Thank you.